Okay, so in this video, we're going to be talking about how to flip rings. So let's go ahead and draw our typical cycloalkane ring and figure out where the groups should be when we flip it. So let's say we have something like, let's say we have something like this. Yep, I don't like that. Like that cycloalkane ring. And let's say we have, at this carbon, we have a chlorine pointing up, so it's axial. And across from it, we have hydroxide pointing down. What I like to do for all of these rings is make a little hinge dotted line, like the hinge of a door. So just go like that. I don't know why it disappears all the time. So there's our hinge, okay? Now when we ring flip, what's going to happen is this side right here is going to go down. So it's going to, on its hinge, it's going to fold down. And this side over here is going to fold up on its hinge. So what's going to happen is you're going to get a structure that looks like that. So the chlorine that we drew, remember it was pointed up, right? It's still pointed up. It's just that the side of the cyclohexane that it was on is now folded down. But it's still going to be pointed in the up direction. So it's going to be like that. And the hydroxide that was pointed down on the left side, it's still going to be pointed down when the ring flips. So in the right-hand structure, the flipped portion of it, the hydroxide is going to be pointed down, but not straight down, but like that. And let's draw in the hydrogens that we know were there. So the OH, the hydrogen on the carbon with the OH was like that, right? And the hydrogen next to the chlorine was like that. So when this flip happened, the yellow hydrogen was pointed down, right? So it's still going to stay pointed down when the ring flips, so it's going to be like this. And the green hydrogen, which was pointed up, is still going to remain pointing up, so it's going to be like that. So let's try this a couple of more times. And if you do this yourself, you're able to draw these structures out very naturally. So let's say we have that cycloalkane ring in the chair configuration, right? And there's our little hinge point where it folds up and down, up and down. So you know that this side is going to be going down when we flip it, and this side is going to be going up. So let's add some functional groups. Let's say we have a chlorine pointing down like so, and over here we have a bromine pointing up. So when this ring flip or ring inversion happens, the left side is now going to be pointing down. So it's going to be like this. And the right side of the ring is going to be pointing up. There's our hinge region and hinge region right there. The chlorine that's on this carbon is over here now. That's the carbon right there. The chlorine was pointing down. So it's still going to be pointing down like that. And the bromine that was on this carbon right here, that's this carbon right there. So I hope you can see that. And the bromine was pointing up in the left-handed structure, right? So it's still going to be pointing up like that. Let's draw in the hydrogens so the picture is complete. The hydrogen on this carbon right here was like that, and the hydrogen on the bromine carbon was like that. The green hydrogen was pointing up before the ring flip, so it's going to remain up after the ring flip, so it's going to be over there. And the yellow hydrogen, which was pointing down, like more down like that, is going to keep pointing down. On the right-sided flipped structure, so it'll be like that. So I know that doesn't look all that great. Let me redraw this thing a little cleaner. All right, that is much better. So there's our hydrogen, there's our chlorine, there's our bromine, and there's its hydrogen. Let's practice that one more time. So let's say we have bromine here and chlorine there. Just draw in your hinge so you can see it better. We're going to be flipping. So this part is going to be going up. It's like a door that's swinging up. This door is swinging down. So it's going to look like that. We put in our hinges. So this, remember, this purple carbon right here is that purple carbon right there, right? But this blue carbon that has the chlorine attached to it is right here. So the chlorine, which was pointed down because its hydrogen was pointing up, this chlorine that was pointed down is going to remain pointing down. So it's going to be like that. And our green carbon, running out of colors here. Okay, let's say our blue carbon, dark blue, which is right here, is this guy right there. And our green carbon that had the bromine, which is right here, is that thing right there. So the green carbon's bromine was pointing down before it flipped. So after it flips, it stays pointed down. So it's going to be like that. And its hydrogen was pointing up. So it's going to stay pointing up like that. And that's all there is to ring flips, okay? Don't make it any more complicated than that. So we'll stop this video right here.